Hello, everyone. Welcome back. Today we are going to be learning about the chain rule and the product rule. We're going to start with the chain rule and then we'll use the product rule. And we'll also move into some problems that use both the chain rule and the product rule at the same time. So basically, the chain rule and the product rule are both rules that help us find the derivative in certain situations. Just a reminder, we've already learned the power rule, right? We already know the rule from before that states that if f of x is equal to x to the power of n, that the derivative is n times x to the power of n minus 1, right? This is a rule we already know. There's a whole video on that rule, so if you missed that one, definitely go back in that one, because in order to do the chain rule questions and the product rule questions and the quotient rule questions next time as well, we first must understand what the power rule is. So I'm going into this assuming that you already are aware of what the power rule is and how to use it. Okay, so let's move on to the chain rule. The chain rule states that if f of x is equal to g of x to the power of n, so basically a function, right? G of x is representing a function to the power of n, then what we do is we, sort of apply the power rule again. We put the n in front, right? We put it in front, and then n minus 1 outside of the function. And we also take the derivative of the function, the derivative of what's inside the function, and multiply it by that as well. And that's the mistake a lot of people make. So, for example, for this one, I see a lot of students making this mistake and saying the answer is 6 times 3x minus 1 to the power of 5. And while that will still get you part marks because that is not entirely wrong, it only accounts for this part of the chain rule and doesn't account for the fact that we also must multiply this by the derivative of what's inside the brackets. So what's the derivative of what's inside the brackets? Well, inside the brackets we have 3x minus 1, and the derivative of this, according to our power rule, which we learned last time, is 3. So therefore the answer is 18 times 3x minus 1 to the power of 5. Let's try another example using the same rule, okay? There we go. So y prime is going to be equal to, well, we got to put the 3 in front and then just copy down g of x. And then the 3 becomes a 2. And then we need to multiply it by the derivative of what's inside our bracket. So derivative of 16x cubed minus 5x squared plus 3 would be what? That would be, let's see, 16 times 3 is 48. So 48x squared minus 10x. And then the plus 3 just disappears. And this will be our final answer. Now we could maybe format it a bit better and say this is 3 times 48x squared minus 10x. And then 16x cubed minus 5x squared plus 3, squared like that. Or we could even, factor out an x from here if we wanted to. But essentially, this is our answer. All right, and how about this one here? It asks us to find the derivative of f at x in this case. Now, the first thing I need to do is I need to get this into a form where we can use the chain rule to solve it. So I'm going to do that. I'm going to say, well, this equation is equal to negative 4x squared plus 3x to the power of 4. So therefore, f prime of x is equal to, negative 4 rather, negative 4 times negative 4x squared plus 3x to the power of negative 5 times the derivative of what's inside these main brackets of our original function g of x, which is going to be negative x or negative 8x plus 3. And there we have it. And, again, I'll format it a little bit nicer, but essentially this is just our answer. All right. So that's the chain rule for you. The biggest thing to remember with the chain rule is it's the same as the power rule with our function, except we also must remember to do this extra step, g prime at x, because that is the most common mistake I see made when it comes to the chain rule. I'm almost on marking tests, almost looking for, okay, did we remember that step or did we not? Because those are really the only two kinds of answers I get on tests, and that's pretty much it. Okay, let's learn the product rule. The product rule states that if we are finding the product, the derivative of a product where we have two functions, f of x and g of x, then the derivative is the f prime of x, so derivative of the first function times the second function just as is, plus the first function just as is times the derivative of the second function. So there it is there. Now, in this case, it actually doesn't matter which order we add these things up in because we're just adding. However, doing it this way every time as a habit is a good habit to get into because it'll help make quotient rule a little bit easier. So always think derivative of the first one times the second, then first one times derivative of the second. Yeah. Or you can even just say remember derivative of the first, and the rest will come at a certain point. Okay, so let's find the derivative of this one. So we know in this case that f of x is equal to x cubed, right? That's the first thing we're multiplying here. G of x in this case is 2x minus 4. So what is f prime at x and g prime at x? Well, let's see. F prime at x is 3x squared and g prime is 2. So now we can use all of this that we just gave ourselves in order to solve the question. So y prime is equal to, according to this equation here, f prime g plus fg prime. So what's f prime? F prime is 3x squared. And what's g? 2x minus 4. And then what's f? X cubed. And what's g prime? 2. So therefore our answer is 6x cubed minus 12x squared plus 2x cubed, which if we simplify that a little bit more, we're going to get 8x cubed minus 12x squared, and that's our final answer. Very good. So notice in this one, we used two rules. We used the product rule, obviously, right? Because this was the introduction to the product rule question. And we also used the power rule, right? We used the power rule to figure out what some of these things over here. And I mean, we also use the constant rule, although I don't really consider the constant rule some big rule, but we also use the constant rule for what it's worth. So I guess technically we use three rules. All right, let's try this one next. Let's try these couple examples. This next example says, find the derivative of h at x in this example. So let's do it. Let's say that this is our f of x, and this is our g of x. F of x and g of x. So f of x is equal to x plus 3 cubed, and g of x is equal to x minus 7 to the power of 6. Now I'm going to find f prime of x and g prime of x. So what is f prime of x? That is going to be 3 times x plus 3 squared. And in this case, we would have to take the derivative of what's inside. However, the derivative of what's inside is just times 1. So we can actually leave it like this, because multiplying by 1 isn't going to actually do anything. And same thing with the other one. We would just end up multiplying by 1. So we don't actually have to write anything there technically in that case. So now that we have this, let's find the derivative of h of x. That's going to be derivative of the first, which is 3x plus 3 squared, times the second, which is x minus 7 to the power of 6, plus the first one, x plus 3 squared, or cubed, times derivative of the second. So that's going to be times 6 x minus 7 to the power of 5. Then I'm just going to clean this up a little bit. The only thing I really need to do here to clean this up is I'm just going to put the 6 out in front of our second main term, x plus 3. But essentially, this is the answer, and that's the nice thing with this power rule, or sorry, not this power rule, this product rule, is that there's not really a lot of solving we have to do, right? You're not really expected to, do all the expanding and simplifying and stuff like that. You can just leave that as is acceptable. Otherwise, you're going to spend way more time on just expanding and simplifying than you would on actually finding the derivative. And that's what we're actually trying to learn. We're learning about finding the derivative. We're not trying to learn how to expand and simplify stuff. There's a video for that too, but that's not the purpose of today. Okay, let's do find the derivative of this one. Okay, so let's first start with defining our terms. So this is going to be our function f of x, and this will be our function g of x. So f of x equals to 3x minus 9 to the power of 4. G of x is equal to 8x squared plus 4 to the power of 5. Now let's find the prime. So f prime of x is equal to 4 times 3x minus 9 to the power of 3. And then, remember, we must also take the derivative of what's inside according to the chain rule. So that's going to be times 3, because the derivative of 3x minus 9 is just going to be 3. The negative 9 disappears, and the 3x becomes 3 after taking the derivative. Okay. Now, what about the derivative of g of x? That's going to be 5, 8x squared plus 4 to the power of 4 times the derivative of what's inside, and the derivative of what's inside is going to be 16x. And there we go. And we could neaten these up a little bit. Actually, you know what? I'm going to do that. I'm going to simplify these a little bit further, because this is also then, this is equal to 12, 3x minus 9 cubed. And then this is equal to, let's see, 16 times 5. That's 80x. 8x squared plus 4 to the power of 4. Because otherwise, we'll just have to do that simplifying later. I might as well do it now, honestly. Awesome. All right, so y prime is equal to y prime is equal to derivative of the first times the second plus the derivative of the second times the first. So I'm going to neaten this up a little bit. But this is essentially the answer. Yeah, let's put the 80x out front. Oh. And there we have it. All right. So let's talk about this last example. It says with more derivative rules, the number of ways to find the derivative of a function increases. Find the derivative of this function using 3 different methods. So method number 1 is the power rule. Method number 2 is going to be the chain rule. And method number 3 is the product rule. Now, the most obvious rule to use in this situation, specifically if we weren't asked to find different methods, would be to just use the chain rule, because clearly this is a function squared, right? So we're going to need to do some chaining in this. However, we could also, if we decided to expand and simplify the equation first and then take the derivative, then we could use the power rule. And if we decided to kind of read this as two products being multiplied together because it is squared, we could use it. We could do the product rule. So we could write this just as is for chain rule. For product rule, we would have to see it more like this. like that. And then power rule, we would have to actually expand it to 4x squared minus 12x plus 9. And then we could take the derivative, right? So we have to rewrite this in three different ways. One way is just, I guess, the same as it already is for chain rule. The other ways we have to rewrite in order to apply those rules. So in this case, we get that the answer is 8x minus 12. And by the way, we should get that for all of them. We should get the same thing for all of them, or we made a mistake. For chain rule, we could say, well, this is equal to 2x minus 3 to the power of 1, and then times 2, right, times the derivative of what's inside those brackets. And that's going to be 4 times 2x minus 3, which is going to be 8x minus 12 once we expand. So we got the exact same thing again. Next, let's use the product rule. So product rule would be derivative of the first, which is 2, times the second, and then plus derivative of the second times the first. So that's going to equal to 4x minus 6 plus 4x minus 6, which is equal to 8x minus 12. So there you have it. So even though the most obvious one to have done would have been the chain rule, it actually looks like the power rule is less steps, right? All I have to do is expand our quadratic, which is very simple, right? If we've made it to this point in math, hopefully that's a simple thing for us to do at this point, and then take the derivative, and there we have it. Whereas the chain rule did require a couple more steps, but it was also pretty fast. Product rule, it required a couple more steps, but it was also pretty fast. None of these were overly tedious, but I still think I prefer the power rule over all of them, even though the chain rule would have been what I would have first thought of when we're approaching this question. So the point of showing you guys this is to show that there's different ways that we can solve the same derivative in some cases. Now, in some cases, there's really only one reasonable way or only one reasonable method to solve a question, but sometimes when it comes to a question like this, there's multiple ways. And no matter which way you use, you will always get the same answer, or at least you should always get the same answer. Otherwise, that means there's been some mistake. But there you have it. That is it for the chain rule and the product rule lesson. Next time we will learn the quotient rule, which is one last derivative rule before we're through.